Hello everyone, so in this session we're going to be looking at laws of indices. We'll look at the stuff that you've already learnt at GCSE and then we'll have a look at the A-level content after that. You'll need your notebook so that when we get to the relevant places we can write some notes, and also you'll need something to write with and something to write on for the examples that we go through. Okay, so we'll start with some laws of indices work that you've learnt already at school. So if you'd like to write down for me, what would this be as a power of A? And you should know that that is a to the power of 10 because we're adding the powers together. Here's your second one. Good, so the answer here is a to the power of 5 because when we divide we take the powers away. And finally, number 3. So in this final example the answer will be a to the power of 12 because we multiply the powers together in this situation. So this slide is going to look at those 3 rules, but in general form rather than with actual numbers. You don't need to write these down in your notebooks just yet because there's a slide later on where you can write them all down together. So in the first example, once again, we are multiplying with the same base and therefore we are going to be adding the powers together. In the second slide, we're going to be dividing with the same base, so we're going to be taking the powers away from each other. And then finally, when you raise a power to another power, we simply multiply the 2 powers together. Okay, so using those laws of indices that we've just looked at, what can we do here? Well, we can take the powers away because we are dividing, and that would give us a result of a to the power of 0. We also know that if you divide anything by itself, you get an answer of 1. And that leads us to recognise quite nicely that a to the power of 0 is equal to 1. In fact, anything to the power of 0 is always equal to 1. In this slide, we're going to start to look at what happens with negative powers. So using, again, the same laws of indices, if we subtract the powers, we get an answer of a to the power of -1. Alternatively, if you imagine as a fraction a to the power of 3 over a to the power of 4, then they would cancel out to give us 1 over a. And so again, quite nicely, we recognise from this slide that a to the power of -1 is equal to 1 over a. Let's take that a little bit further. So again, using laws of indices, a to the power of 4 divided by a to the power of 7 would result in a to the power of -3. And once again, if you imagine a to the power of 4 over a to the power of 7 as a fraction, if you simplify that fraction, it would become 1 over a cubed, and therefore a to the power of -3 equals 1 over a cubed. Or more generally, a to the power of -n is equal to 1 over a to the power of positive n. So here are 5 questions that you can have a go at yourself. In this question, we're trying to simplify each of these expressions to give a power of 2. So we're going to use our laws of indices, and you can pause this PowerPoint now, have a go, and then in a couple of minutes I'll go through the answers. Okay, so let's go through them then. So in A, 2 to the power of 4 divided by 2 to the power of 6, we're going to subtract the powers, and then we're going to multiply by 2 to the power of 8, which is when we add the powers, resulting in an answer of 2 to the power of 6. In B, same rules apply, so we're going to add the powers in the numerator to give 2 to the power of 12. We're then going to take the power of 8 away from 12 to leave us with 2 to the power of 4. In C, the alternative way of writing the fraction is 2 to the power of -7. So then when we add the power of 9 onto the -7, we get 2 squared. And then in D and E, and this is a very common type of question in an exam, they're expecting you to change the 8 and the 4 into powers of 2, then simplify and then come up with an answer. So the 8 would be 2 cubed. So 2 cubed divided by 212 would be 2 to the power of -9. And then if we change the 4 to 2 squared, we then would again take away the powers to give 2 to the power of -4, and then we would subtract those powers because we're dividing. Be careful of the double negative, and you should end up with an answer of 2 to the power of -5. And then finally in part E, 16 can be written as 2 to the power of 4, 1 over 2 to the power of 5 can be written as 2 to the power of -5, 8 would be written as 2 cubed, but then when we square that it becomes 2 to the power of 6 because we're multiplying the powers. And then finally, if you use those laws of indices, we end up with 2 to the power of 15. So well done if you got all those right. If you didn't, then have another go. Now what we're going to do is write these expressions in the form a to the power of n times a to the power of n, and this is going to lead nicely onto our next law of indices. So a squared, how can we write it in that form? Well, we would write a squared as a times a. Similarly, a to the power of 4 could be written as a squared times a squared. A to the power of 10 would be a5 times a5. And then a little bit more tricky, a to the power of 1 if you like, would have to equal a to the power of a half times a to the power of a half. So that previous slide links nicely into this one, but in this question we are trying to find the value of x. So what number when you multiply by itself gives you 9? The answer would be that x is 3. In the second one, similar but a little bit more difficult because 8 is not a square number. What number when you multiply by itself gives you a value of 8? The answer to that would be that x is root 8. And then more generally, what would x have to be in order for us to give us an answer of a? X would have to equal the square root of a. So in our first slide that we just looked at, we recognise that a to the power of a half times a to the power of a half is equal to a. In the slide I've just shown you, we also recognise that root a times root a is equal to a, and therefore if we combine those two, we can see that root a therefore is equal to a to the power of a half. Using similar logic, we can deduce that a to the power of a third is equal to the cube root of a, which then leads to the general rule that a to the power of 1 over n is equal to the nth root of a. And that's our next law of indices. And then we've just got one more law of indices to look at, and that's what happens if you have a fractional power, m over n. So the first thing we can do is write a to the power of m over n like so. That's just using a bit of fraction multiplication. That then leads to this, which is using our third law of indices, where you have a power raised to another power. We talked about that earlier on. And then that leads on to this, because again we discussed earlier that a power of 1 over n is the nth root. And the alternative to that is having it written this way around. So in essence, what we're saying here with this final law of indices is that if you have a fractional power, the numerator is the power and the denominator is the root. And it doesn't matter which way round you do that. So you could work out the power first and then the root, or you could work out the root first and then the power. Okay, good. So this is where you need to get your notebooks out, and if you put the title in your notebook, Laws of Indices, you can write down these 6 laws of indices that we've just derived, and these will be used in exam questions, exercises, etc. So here's 4 questions for you to have a go at yourselves. A bit trickier than last time, although we're still writing these expressions in the form 2 to the power of x. But it will use all of the laws of indices rather than just the few that we were doing before. So I'll leave you to have a go at these for a few minutes, and then I'll go through them after you've had a go. Okay, so in this first one, we've got 2 to the power of 4, nothing we need to do with that. Root 2 is 2 to the power of a half, and then if we subtract the powers, we get 2 to the power of 7 over 2. Better to write that as a improper fraction. In B, we've got the cube root of 2, which we can write as 2 to the power of a third. In the second term, we've got 2 cubed and then the fourth root, which we would write as 2 to the power of 3/4. And then if we take those powers away, we end up with 2 to the power of minus 5/12. Perfectly okay to have a negative power. In C, your first job would be to change the 4 to 2 squared, and then we're taking the cube root of that, so that'll be 2 to the power of 2/3. And then 1 over that will be 2 to the power of minus 2/3. In the second term, 4 is 2 squared, 8 is 2 cubed, but we're square rooting that, so that's going to be 2 to the power of 3/2. And therefore, if you do 2 squared divided by 2 to the power of 3/2, you're going to get 2 to the power of 1/2 because you're taking the powers away. And then when you multiply those two terms together and add the powers, you get 2 to the power of minus 6. And then finally in D, 32 is 2 to the power of 5. 4 is 2 squared, but when you raise that then to the power of 7, it's going to become 2 to the power of 14. So altogether on the top, you're going to have 2 to the power of 19. And then on the bottom of the fraction, you've got the cube root of 2 to the power of 10, which can be written as 2 to the power of 10/3. And then when you divide the numerator by the denominator, you take the powers away and you end up with 2 to the power of 47/3. Okay, good. And then the final part of this presentation involves solving equations that involve indices. So this example can be done in your notebook. There's a few ways of going about this question, so if you have a go and find that you've got the right answer but you've done it in a different way, then that's fine. But I'll go through the steps that I would take to solve this equation. So first of all, I would be writing that x to the power of minus 3 is the same as 1 over x cubed, so getting rid of that negative power. Secondly, I'm getting rid of the fraction on the left hand side by multiplying both sides by x cubed, and then isolating the x cubed by dividing by 8 to give us x cubed equals an eighth. And then finally, if I take the cube root of an eighth, or similarly written as an eighth to the power of a third, we will end up with a half. And this final question is another one for your notebooks, and it's an equation that we need to solve, and within it we need to find the value of x. So how do I go about this? Well, my starting point would be to recognise that everything within this equation can be written as a power of 8. So I'm going to first of all change the relevant parts to powers of 8. So on the left hand side, I'm going to change root 8 to 8 to the power of a half. Law of indices. And on the right hand side, I'm going to change 64 to 8 squared. Then using several laws of indices that we've looked at on the previous slides, I'm going to change the left hand side to 8 to the power of x minus a half, and on the right hand side 1 over 8 squared is the same as 8 to the power of minus 2. And now what I can do is a comparison of left hand side and right hand side, because they are both powers of 8. So logic tells us that x minus a half therefore must equal minus 2, which then leads to an answer of x equals minus 3/2. And this question can be written down in your notebooks as well. And that's it. So the final thing left to do is to practice those skills. And we can practice those skills using this exercise on page 8 of your textbook. Feel free to have a go, mark them yourself. Any problems, get in touch with your teacher, either through email or through Teams. And that completes our work on laws of indices.